Ladies and gentlemen, it is a great honor for me to present my paper entitled Symmetry in Design and Analysis of Some Spatial Structures during such an excellent scientific conference organized at the University of Surrey. The consideration of basic rules of symmetry, together with application of principle of superposition, has always been present during the design processes carried out by myself in the field of shaping and analysis of various types of the spatial structures. This slide presents schemes which explain basic rules of the two-stage method of approximate calculation of statically indeterminate trusses. In each stage, one should remove a number of members equal to the statically indeterminacy of the basic truss, respectively at first from its top chord and then from the bottom chord. On this slide are presented procedures and results of calculations obtained in the both stages of this method. Each of the statically determinate trusses has to be loaded by the forces having half values of the load forces applied to the basic truss. From the previous comparative analysis follows that the accuracy of the two-stage method is good enough for needs of the structural design of the most types of the statically indeterminate plane trusses. The tension-strut structural systems are very often applied as the bearings lightweight structures of the large span roofs. On the next two slides are shown general schemes of selected types of such structural systems, which I worked out by suitable applications of modular units having the form of a tetrahedron. The first group of such structures is built by means of the inversely directed tetrahedron modules located on both sides of the triangular hexagonal grid. The whole structure has to be appropriately pre-stressed. The second group of such structural systems is shaped by the usage of the tetrahedral modules, this time spaced over every second triangular field in the lower or upper part of each of the concentric cubes. The next proposed technical solution is called the Composite foundation system. It has been invented for the needs of construction of heavily loaded buildings located on subsoil of very small load-carrying ability or in the earthquake-prone areas. The point of this system is as follows. In a narrow space between two horizontally located beams is arranged an intermediate structural system which is connected to these beams by the means of nodes uniformly distributed along the neutral axis of the beams. The intermediate system is built of two subsystems. The first one is called the tensile construction system, while the second one is called the arch system. The lenticular form of the intermediate system is considered as the modular unit of the foundation. It can be repeated many times along the horizontal direction, what implies that the surface of this foundation can be theoretically unlimited, due to which it can be a large and stable base for the megastructures. I have proposed the composite foundation system as a structural foundation in the three conceptual designs prepared for the series of the International Evolo Skyscraper architectonic competitions. The first one is called the Geodome Sky Towers. Each of the towers is of a height equals around 380 meters. The foundation base has form of a square. Its edge length equals around 250 meters. Its construction depth equals 18 meters and it contains three technical stories. The central geodesic sphere has diameter equal to 100 meters. The ocean again is designed as the floating structure in subtropical ocean areas in the far distance from a land, being an independent settling unit that is self-sufficient in terms of energy and food supply, and be able to house a group of around 150 persons. Spatial modules of the system of composite foundation can be made as the huge, mostly trapezoidal, waterproof boxes having substantial buoyancy forces. That is why they could be the component parts of an artificial island able to float on the sea. The circular platform of the ocean IASS has slightly more than 400 meters in diameter. The floating bay tower is designed by application of similar waterproof boxes, and the complex can move vertically only, depending on the current sea level. The structural solution is proposed for objects located within tranquil bay areas, which in addition are surrounded by piers and special breakwaters that limit non-uniform and sudden sea level rises. After reviewing all the presented examples, one can state that the simple rules of symmetry, together with the principle of superposition, have always been very helpful in the fascinating process of shaping, design, and analysis of various types of the spatial structures. Thank you very much for your kind attention.